Since we have now our equation for an undamped free vibration system, MDOF system, just like in the SDOF system, di ba, when we arrive with this equation, so next ito baton, pangitaan na to siya og solution. Unsa man ang solution ani niya. Di ba in the SDOF system kay lahi man to naman tay mga actually similar man gid siya, but in the MDOF system natay additional na nga solution. The solution is in the form U is equal to phi sine omega t plus minus theta. You're already familiar with omega, di ba, right? That is our natural frequency. The t, of course, this is the time. Karon kinsa man na, sir? Si phi. Si theta. Theta sa tao na. Theta. We call this our phase angle. The phase angle in this equation or solution, this represents or reflects the time lead or time lag of the vibration. Unsay pasabot ana, sir? Kana siya nagrepresent na siya kung ang imuhang vibration, the time of your vibration is nag-una ba siya or ulahi siya in relation to your forcing function. Pwede na ninyo kinahanglan problemahon kay nga naman dili man nato ni siya magamit og ayo. Kinsa diyang magamit sa added terms? Di ba we have the unadded terms? We have that the theta and the phi. Ang pinakagamit kay nato is si phi. Why? We call this our mode shape factor. And this is the very focus in the MDOF system. We're going to get the mode shape factor in different structures. So in the SDOF system, atong ginakuha is the deformation, velocity, and acceleration. In the MDOF system, we are going to get the mode shape of the building or the mode shape factor. So the mode shape factor shows us the mode shape of the building. Unsa ding naa sa mode shape? Actually, that's why we call this the mode shape analysis. Why? What's with mode shape? Kana si mode shape, mo na siyang gako ano. It represents the pattern of deformation structure at specific frequency. So di ba na natural frequency si SDOF system? And since we have an MDOF system, multi-degree of freedom system, we cannot only expect a single natural frequency of the system. E multi-degree man siya, multi-degree sad ang natural frequency. And each frequency, na siya ilay nga deformation, right? Ang iyang pattern ana, katong pattern of deformation ni first floor, second floor, third floor, fourth floor, fifth, sixth, up to 10th, or whatsoever. The pattern of that in its natural frequency, atong tawagan na mode shape. Saan na to pagkahibala sa mode shape? Kuhaon na to si mode shape factor. We call that phi. Okay, let's continue with our general solution. So we just differentiate u. We have u dot at phi omega cosine omega t plus minus theta. And we differentiate that, we'll get our response acceleration is equal to negative phi omega squared sine omega t plus minus theta. And then we just substitute this to our matrix, not our equation. And then it will be in this form. And if you notice, we have common factors, sine omega t plus minus theta. And then we can just remove that. We divide sine omega t, sine of omega t plus minus theta. Now we factor it out and divide that value to the whole equation. We are then left with this one, negative omega squared times the mass matrix times the phi or the mode shape vector plus the stiffness matrix times the mode shape vector. Mingon nga nitong vector, daghan na siya value. Diba, prani ni acceleration vector. So, when you say acceleration vector, sa to pa na dito yung acceleration 1, acceleration 2, acceleration 3, etc., etc. So, this one, we have a mode shape vector. Pasabot na tayo mode shape 1, mode shape 2, mode shape 3, so on and so forth. We rearrange that into this form, stiffness matrix times the phi minus omega squared times the mass matrix times the phi is equal to the null vector. We just factor out the phi or the mode shape factor. We have this in this form is equal to the null vector. Karon natin mga unknowns aning part. And to get the unknowns, no, we are going to apply determinants. No, we are going the operation. So kuha na tog determinant stiffness ang stiffness matrix minus omega squared times the mass matrix, this part. And after that, no, later in our calculations ato na makita. So these are in the mode shape analysis, these are the steps that we are going to take. First, we need to ensure we need to get first the stiffness matrix and the mass matrix, and then we're going to get the difference of the stiffness matrix minus the omega squared times the mass matrix. Afterwards, after getting the difference, let's get the determinant of that difference. After getting the determinants, we can now, because the unknowns is already solved in that part, we can now get for the mode shape factors. I'm talking about the phi. And lastly, we can then sketch the mode shape.